Hey guys, Lindsay here, and today we're going to take a look at finding the greatest common factor. And we're going to kind of break it up into a couple pieces just to make it a little bit easier to follow. First, we're going to take a look at finding the greatest common factor of these two sets of numbers, and then we're going to get into some letters, and then at the end we'll put them together. So first, let's take a look at just worrying about finding the greatest common factor. Often we see GCF, just so we don't have to write that thing out every time, of 24 and 16. So basically what we're going to do is we're going to work these individually. We're going to look at 24 first, and we're going to say what are all of the numbers that divide evenly into 24. And I'm going to write a big long list. You don't have to do it that way, but maybe when you're not comfortable, it's a good way to do it. And then you get better and better at doing it in your head. So I'm looking at 24, and I know that 1 will go evenly into 24, 2 will go, so 3, 4 will go evenly into 24, 5 wouldn't. If you did 24 divided by 5 in your calculator, you'd get a decimal. 6 will go into 24, so will 8, 12 will go into 24, and then 24 would also go into 24 just once. So that's all I can think of all of the numbers that would divide evenly into 24. Let's do the same for 16. So 1 goes in, so it's 2. 3 doesn't, but 4 does. 8 does. And 16. So those are the numbers that will divide evenly into 16. Now I'm going to take a look at both of those lists, and these are the factors of 24. Those are the factors of 16. This says greatest common factor. Greatest meaning the biggest number, and common, meaning they have them in common. They're the same. So I'm going to look on these lists, and I'm going to say the biggest number, look, they both have a 1, they both have a 2, but the biggest number on both of those lists is 8. So in this case, the greatest common factor of 24 and 16 is 8. Biggest number they have in common as factors. So why don't you take a minute, turn off the video, or pause it, maybe I want you to come back, but pause the video and try to find the greatest common factor of 12 and 18. And then you can come back and you can check your answer with mine. So hopefully you did that. And now we're going to take a look at these numbers together. So 12, all of the numbers that will go evenly into 12. 1, 2, 3, 4, 6, and 12. That's lots of numbers. Going to do the same for 18. So 1 will go into 18, 2, 3 will, 4 doesn't, 6 does, and 9 does, and I think 18, that's it. Okay, so there are my list of factors for each of them. I'm going to look at this list and I'm going to find the greatest one they have in common. They have 1 in common, they have 2, they have 3, but 6 looks like the greatest common factor of those two numbers. So hopefully that makes sense in terms of the greatest common factor for a number. Now let's talk about when we're dealing with letters, because in algebra we're dealing with letters quite a bit. So we're going to do this one a little bit differently. The way that we're going to do it is we are first going to look at the first value. This says x squared y to the power of 4. And we are going to write that in expanded form. What I mean by that is x squared really means x times itself twice, and y to the power of 4 means 4 y's. 2, 3, 4. So this is the factors of x squared y to the power of 4. And I'm running out of room here, so I'm going to bring this guy down. Maybe you're wondering why I did the long one at the end. So am I right now, but that's okay. Let's now take a look at x to the power of 3y. Now, x to the power of 3y means really 3 x's and 1 y. It's invisible, but it's there. So if I'm going to write this in terms of factors, I'm going to write 3 x's and 1 y. So there are the factors of this guy. Now I'm going to figure out what they have in common. It looks like there's 2 x's here and 2 x's here. I can't include that guy because this guy doesn't have 3, he only has 2. And what they have in common in terms of y, it looks like they only have 1 y in common. So hopefully that makes sense that I'm drawing a box around whatever they have in common, which means the greatest common factor of x squared y to the power of 4 and x cubed y would be 2 x's and a y, which you could write like that, or you could write x squared, 2 x's, and y to the power of 1. There's your greatest common factor. So why don't I take a minute and give myself a little bit of room, and then let's do a question in combination with both numbers and letters. Okay, we're back, and we're just going to take a look at these two questions. And this time, instead of finding the greatest common factor, what we are actually going to do is factor these. There's just one little extra step, which we'll talk about. Okay, so in order to factor this question, 25x to the power of 3 y squared plus 15xy, we are first going to look for the greatest common factor. And the interesting thing about factoring questions is they often don't tell you which kind of factoring they're expecting, but the important thing is that we first always look for a greatest common factor before we try to factor any other way. So in this question, that's all we're going to do is find to factor it using a greatest common factor. So if I'm looking at these, what I'm going to do is what I did a minute ago. I am going to first just focus on the numbers. I've got 25 and I've got 15. Now maybe you need to draw that list out, all of the numbers that go evenly into 25 and all the numbers that go evenly into 15. Or maybe you can look at those two numbers and you can say, you know what, 5 is the biggest number that goes evenly into both of those. If you had to do the list to do that, totally okay. Eventually you'll get more comfortable though. Now we're going to take a look at the letter portion of this. X to the power of 3, 3 x's. Y to the power of 2, 2 y's. Over here, it's just xy, which really, that's x to the power of 1, y to the power of 1. This guy only has 1 x and 1 y. So if I want to find the greatest common factor between the two of those, it looks like all they have in common is 1 x and 1 y. You don't have to write the ones there, but you can if you want to. This is the greatest common factor right here, 5xy. And if the question says, find the greatest common factor, that would be your answer. You're done. But it doesn't. The question actually says factor. So what we have to do is we have to figure out, factoring's kind of like doing multiplication backwards. We have to figure out what's going to go inside of this bracket. So we need to look at 5xy, and we need to say, okay, there's a plus here, so I'll put a plus in the middle. What do I have to multiply 5xy by to get my first number? 25, x to the power of 3, y to the power of 2. First the numbers. 5 times what is 25? Well, 5 times 5 is 25. Now, x to the power of 1 times what would give me x to the power of 3? Looks like we're missing just 2 x's. X to the power of 1 times x to the power of 2. That would give me x to the power of 3. And now I've got y to the power of 1. Well, if I have another y to the power of 1, y to the power of 1 times y to the power of 1, got my y to the power of 2. There's my first value. The second value, 5 times 3, would give me 15. And I've got x to the power of 1 and x to the power of 1. Well, we've already got the x there. I don't have to put any more x's there. And also, y to the power of 1, y to the power of 1. I don't have to put any more y's there either, because 5xy times 3 would give me 15xy. So I can actually finish it off like that. So again, in factoring, using the greatest common factor, you first find that factor, but then you've got to put in the bracket what you have left over. And again, think of it like multiplying backwards. 5 times 5 would give you 25. X to the power of 1 times x to the power of 2, x to the power of 3. Y times y is y squared. Same with that. So you're kind of doing it in reverse. So why don't you take a minute, look at these, and see if you can come up with not only the greatest common factor for those two values, but also what you have left over in the bracket so that you've completely factored it. So take a minute, pause the video, do that one, and then come on back to me and we'll do the solution together. So hopefully you did that. And I'm going to do this one now for you. First, we're going to focus on numbers, then we'll worry about the letters. I've got 100 and I've got 60. And if you did that list underneath both of those numbers, hopefully you realized that 20 was the biggest number that goes evenly into both of those. Now we're going to look at the a's. This guy has 2 a's, and so does that guy. So our common factor can have 2 a's as well. 4 b's and only 1 b. So it looks like they only have 1 b in common. Again, you can put the 1 there or not. It's up to you. Now let's figure out what goes in our end bracket here. 20 times what gives me 100? 20 times 5 will give me 100. A to the power of 2 and a to the power of 2, I don't have to add an a there because they're both there already. All I have to do is, looks like, have 3 b's. B to the power of 1 times b to the power of 3 would give me that one. And now 20 times what would give me 60? That's 3. A and a, oh, they both have a to the power of 2. I don't have to worry about it. And actually, they both have a b to the power of 1, so I don't have to worry about that either. So this is complete. So we're done. So hopefully that helps you understand a little bit better the concept of factoring, finding the greatest common factor, because again, that's sort of the baseline for factoring. If a question says factor, start with the greatest common factor and then move to different types of factoring after that.